Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Modeling with Linear Functions, Unit 4, Lesson 6. I want to talk about some critical linear model facts. All linear models in the form y equals mx plus b have two parameters, the slope and the y-intercept. Remembering that the slope is m and the y-intercept is b. The slope, m, always tells us how fast the output is changing relative to the input. For every and to simplify that, remember the formula rise over run. That is my ratio, rise over run. The y-intercept b always tells us how much we start with, or the output starting value at x equals 0. So that's my b. Where am I going to begin? And in that case, my x is always 0. And I'm going to be moving up and down on my y-intercept. In exercise number 1, Janine has $450 in her savings account at the beginning of the year. She places money in the account at the rate of $5 per week. We want to model the amount of money she has in savings S as a function of the number of weeks she has been saving W. So A, fill out the table below for some of the number of weeks. Show the calculations that result in your answer. So the first thing I want to fill out, at 0 weeks, how much money will she have? Well, it's going to be $450. That's what she's starting off with. It says Janine has $450 in her savings account at the beginning of the year. Now, after 1 week, I'm going to say 450 plus $5 per 1 week. That's going to give me $455. In 5 weeks, I'm going to do 450 plus 5 times 5, which is going to give me $475. And then 10 weeks, I'm going to do 450 plus 5 times 10, and that's going to give me $500. If I were to write an equation using this information as a linear function of the weeks she has been saving, it would look like this. My savings would equal 5W plus 450. For my opening definition, my y-intercept is my starting point. As you can see, my x value is 0. My y value would be 450. That is why this is my y-intercept. Once again, I'll take the time to highlight this as my y-intercept, noticing that my x value is 0, so therefore my y-intercept is 450. That's how you identify what is your y-intercept. My 5 is what it's going up by each week. It's very noticeable. From 0 weeks to 1 week, it went up $5. So that's why it's 5W. If it went up $10, then it would be 10W. Let's take a look at C. If Janine saves for exactly 1 year, what is the range in her savings over the year? Well, one of the things that we have to calculate before we can understand that is that there are 52 weeks in 1 year. Okay? And in order to solve that, I have to solve how much she can save in 52 weeks by doing 450 plus 5 times 52, which is going to give me 710. Now it talks to me about range. What is the range? So where do I start? I start at $450 less than or equal to y less than or equal to 710 at 52 weeks. So that's my range. E. I would like to use 2 points from the table to verify that the rate of change of this function is 5. So it basically is asking me to prove that the rate of this function is 5. So I'm going to take two different points. I'm going to take 5 comma 475, and I'm going to take 10 comma 500. And now I'm going to do my formula. I'm going to do my delta y over delta x, which that formula is my slope formula, is y2 minus y1 over x2 minus x1. One of the things I really want you to get in the habit of doing is identifying these points as x1, y1, x2, y2. Let's get in the habit of really putting those points in there. So now I'm going to have 500 minus 475, and I'm going to have 10 minus 5. 500 minus 475 is going to give me 25 over 5. 25 over 5 equals 5. So choosing these 2 points verifies that my rate of change for this problem is 5, which I can put right in there. We're going to skip exercise number 2. We're going to do that as a lab. So let's go ahead and look at exercise number 3. Amanda is walking away from a light pole at a rate of 4 feet per second. Underline key information, please. If she starts at the distance 6 feet from the light pole, which of the following gives her the distance d from the light pole after walking for t seconds? So this really stresses what we just talked about and understanding my y-intercept and my slope and what they actually mean in real life situations. So the first thing I did was I drew a light pole, just so that I had a visual. She started right here before she started walking, this far away from the light pole. That distance was 6 feet. After that point, she walked in 1 second 4 feet. So if I were to write an equation, I'd have my distance equals my starting point. If I'm starting at 6, that's going to be my y-intercept, so plus 6. And my slope would be how much it's changing per second. Well, in this case, it's going to be 4 feet per every second. So my slope is 4 feet. So it's 4x plus 6. So that would be choice number 1. Having this concept down will definitely help us in our lab question for exercise number 2. But before we go on, I would like you to think about on that first page of notes, I would like you to go back and look at D. And I want you to try to come up with an answer for that. And we're going to have a discussion about D in class. Make sure that you have D done if you would like full credit on that homework assignment. Have a great evening. Have a great day. Signing out, Mr. Payne.